Okay, this new video is gonna simply continue working on more problems where we differentiate from first principles. You remember in the video I just did, I solved several problems. I think f of x is x squared plus 1, f of x is x cubed, f of x is root x, and f of x is equal to 1 upon root x. I'm going to do all the remaining problems in this set, and then I'm going to give you a set for homework. So here we go. I'm continuing. The function I have to differentiate from first principles is f of x is equal to the root of ax plus b. That would mean that f of x plus delta x is equal to the root of a into x plus delta x plus b. And we know that f prime of x, the first derivative, is equal to f of, is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all divided by delta x. Isn't that right? If we were to substitute, f prime of x is equal to the limit as delta x approaches 0 of the expression for f of x plus delta x would be the square root of a into x plus delta x plus b minus f of x, which is just the root of ax plus b, and I'm going to divide that by delta x. Substituting delta x equals 0 directly into that will give me 0.0, which is undefined. So how do I massage this? Well, it looks like I gotta rationalize my numerator. So I'll pull the function out before and do exactly that. Consider the root of a into x plus delta x plus b minus the root of ax plus b upon delta x. Rationalizing it means multiplying both numerator and denominator by the conjugate of the numerator. The conjugate of the numerator would be the root of a into x plus delta x plus b plus the root of ax plus b upon the root of a into x plus delta x plus b, again, plus the root of ax plus b. Shortcut means multiply first by first, last by last, put a minus sign between them. So if I multiply the root of a into x plus delta x plus b by the same thing, I will simply get a into x plus delta x plus b. Minus, if I multiply the root of ax plus b by itself, I will simply get ax plus b. So the numerator has been simplified a bit. And in my denominator, I have delta x times the root of a into x plus delta x plus b plus the root of ax plus b. If I open up my numerator, I will get what would I get? I got this bracket in the wrong spot. No, I don't have it in the wrong spot. I have it right. This a just governs the x plus delta x. All right, so in my numerator, if I open up the brackets, I will get ax plus a delta x plus b and push the minus inside that second bracket, I'll get minus ax minus b. In my denominator, I still have all that stuff left, which is delta x all into the root of a into x plus delta x plus b plus the root of ax plus b. Close off that bracket there. This thing must look like an x, man. Make it look like an x. Yeah, it looks a little more so, I guess. Okay. So let's see what cancels out. Ax goes out with minus ax. B goes out with minus b. 1, 2, 3, 4, 5. So 4 terms go out. What's left? A times delta x. The delta x will go with that delta x. What's left on top? A alone. All upon the root of a into x plus delta x plus b, like that. And then plus the root of ax plus b. So f prime of x is therefore the limit as delta x approaches 0 of that a upon the root of a into x plus delta x plus b plus the root of ax plus b, like so. And if I put delta x equals 0 now, I'm actually finding the limit. A stays on top. On the bottom, it'll be the root of a into x plus 0. Remember, I'm putting 0 where I see delta x plus b plus plus the root of ax plus b. Like that. Which gives me a upon the root of ax plus b plus ax plus b plus the root of another root of ax plus b, and the root of ax plus b plus the root of ax plus b is 2 times the root of ax plus b. So if f of x is equal to the root of ax plus b, then f prime of x is equal to a upon 2 times the root of ax plus b by first principles. You want us to check it using standard differentiation? That wouldn't be a bad idea. I think we're right. We could probably even do that in mental. We're so good. We're so good. F of x is equal to the root of ax plus b, which is ax plus b to the half. And the chain rule, drop the power. F prime of x would be a half into ax plus b. Subtract 1 from the power. Power is minus a half. Times the derivative of what's inside, which is a. Okay, 2 is already in my denominator. Yes, 2 is already in my denominator. If I drop the ax plus b to the minus a half down to join it, the only thing that would be left on top is the a upon 2 times ax plus b to the half, positive a half. And of course, you can write that as a upon 2 times the root of ax plus b. So we're good. We're good. All right, I'll actually leave that. This is classical differentiation. This one is first principles. Everything we did above there. All right. Let's do the next one. Tidy up the end here. Oops. Gone too far over. All right. The next one. What was the next one? The next one was 1 upon the root of b minus ax. So I just did this one. Now I'm about to do that one. 1 upon the root of b minus ax. Let's see what classical differentiation is going to give us first. F of x, 1 upon the root of b minus ax. If I throw it up, it'll be b minus ax to the minus a half, which is minus a half into b minus ax to the minus 3 halves. And then differentiate inside and you get minus a, right? Which will give me minus a plus. So a stays on top, 2 is already at the bottom, and if I throw down the b minus ax to the minus 3 halves, it becomes b minus ax to the positive 3 halves, which you can probably rewrite as a upon 2 times the root of b minus ax all cubed. Right, this is f prime of x. F prime of x here. So this is classical differentiation. Let's see what first principles does for us. A lot of this is algebra intensive. All right, 1 upon the root of b minus ax. Let me justify this thing, man. F of x, 1 upon the root of b minus ax. First principles will basically say that this is f prime of x, not f prime of x yet, f of x plus delta x. F of x plus delta x will be 1 upon the root of b minus a into x plus delta x. Remember, the only thing you're doing to get f of x plus delta x is to replace x with x plus delta x everywhere. Okay, let's find f prime of x now. By definition, f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all upon delta x. So I'll take the f of x plus delta x minus, I can see this is a complicated looking expression, and I'll work on it on the side right now. F of x plus delta x minus f of x all upon delta x is equal to 1 upon the root of b minus a into x plus delta x minus f of x would be 1 upon the root of b minus ax, and all of that is divided by delta x. If I convert the numerator into a single fraction, its LCM will be the root of b minus a into x plus delta x times the root of b minus ax. And in my numerator, I will have the root of b minus ax minus the root of b minus a into x plus delta x. Your algebra should be good enough at this point. I shouldn't have to explain the details in between there. All divided by delta x still. Okay, what do I do next? I'll merge these two denominators into one. Remember, this is like delta x over 1. If you upturn and multiply, these two denominators merge into 1. So f of x plus delta x minus f of x all divided by delta x is the same expression as the root of b minus ax minus the root of b minus a into x plus delta x all upon delta x times the root of b minus a into x plus delta x times the root of b minus ax. Looks like I have to rationalize my numerator here. I'll just come across a little bit. So I'll multiply top and bottom by the conjugate of my numerator again. So this will be times the root of b minus ax plus the root of b minus a into x plus delta x upon, same thing, the root of b minus ax. My root looks a little shaky there. The root of b minus ax plus the root of b minus a into x plus delta x. Okay, if I rationalize my numerator, it's first by first minus last by last. Okay, so the expression for f of x plus delta x minus f of x all over delta x becomes first by first, which is the root of b minus ax times itself, root of b minus ax, just gives me b minus ax. Minus, last by last, gives me the root of b minus into, the root of b minus a into x plus delta x times itself will give me b minus a into x plus delta x. All divided by lots of stuff. Delta x times the root of b minus a into x plus delta x times the root of b minus ax times, I'm going to open up a bracket here because inside I got a plus sign. So everything out here is times the root of b minus ax plus the root of b minus a into x plus delta x. Yes, I know it's algebra intensive, but you got to keep your head on. All right, let's see what happens. If I push this minus sign inside in my numerator, I'll get a minus b, which will cancel out with this b. So b and minus b will cancel out. That minus will make up, minus and minus gives me a positive a in front of the ax plus delta x. So plus ax and the minus ax in front there will cancel out. And the only thing that will be left in my numerator is a delta x, a positive a delta x. F of x plus delta x. All right, all the way over. F of x plus delta x minus f of x upon delta x is equal to just a negative a left on top. If you are unsure, open up all the brackets one at a time, and you're going to see that that's the case. Minus and minus gives me a plus a. Let me double check. So it's plus ax and minus ax will cancel out. Minus b and plus b will cancel out. And plus a times delta x is left on top. And by the way, the plus a times delta x will cancel out with this. Not the a. The a is not going to go anywhere. All right, I'll go through the steps. Yes, I'll keep this delta x here. Minus a times delta x is left on top, and on the bottom, I'll have delta x times the root of b minus a into x plus delta x times the root of b minus ax times the root of b minus ax plus the root of b minus a into x plus delta x. Mercy. All right. Delta x you can clearly see canceling out with delta x there. What's left for the expression for f of x plus delta x? F of x plus delta x minus f of x all upon delta x. Now it looks like minus a on top all upon the root of b minus a into x plus delta x times the root of b minus ax times the root of b minus ax plus the root of b minus a into x plus delta x, like so. Okay, so I have to find the limit of that as delta x approaches 0. So therefore the limit as delta x approaches 0 of f of x plus delta x minus f of x all upon delta x is the same as the limit as delta x approaches 0 of this expression on top here. I'll write it back. It's painful to write this so many times, but I will. The root of b minus a into x plus delta x times the root of b minus ax times the root of b minus ax plus the root of b minus a into x plus delta x. All right, everywhere I see delta x now, I'm going to plug in 0. So you got to follow the algebra. This becomes minus a is on top. What's on the bottom? The root of b minus a into x plus 0, which is just b minus ax. So b minus ax times this other b root of b minus ax. Right? There was no delta x to plug into this part, right? Okay. And then into, got rid of my root there, into the root of b minus ax plus, and the root of b minus ax, the delta x goes to 0. Oh wow. So let's see. This is f prime of x. Minus a is left on top. And on the outside, the root of b minus ax times the root of b minus ax is just b minus ax. And inside the brackets, the root of b minus ax plus the root of b minus ax is 2 times the root of b minus ax. Remember, something plus itself is 2 times the same thing. Okay. Which is minus a upon b minus ax. I pull the 2 to the front. And the root of b minus ax is b minus ax to the half. And b minus ax times b minus ax to the half. Add the powers, indices. Minus a upon 2 into b minus ax all to the 3 halves. Or if you choose to, minus a upon 2 times the root of b minus ax all cubed. So if I were to summarize, if f of x is somewhere up here, 1 upon the root of b minus ax, yes, 1 upon the root of b minus ax, f prime of x will give me minus a upon 2 times the root of b minus ax all cubed. I like them apples. Yeah, them apples nice. Yes, that's that one. All right. So I've given you pretty much several different versions of the expressions they can give you. You know, polynomial, roots of polynomials, and so on and so forth. What was the next one in line? Oh, I had sine x and then cos 2x. Let's jump to a trig function. Everybody knows when you differentiate sine x, you get cos x. Oh, these people are bright bad. Okay, so let's see how first principles gets us there. End this one off. Yes, all right. Kind of is. All right. We know that f of x is equal to sine x. So therefore, f of x plus delta x is equal to the sine of x plus delta x, like so. Okay. By definition, f prime of x will be the limit as delta x approaches 0 of f of x plus delta x minus f of x, all divided by delta x. F prime of x is the limit as delta x approaches 0 of sine of x plus delta x minus sine x all up in delta x. If you try to plug in delta x equals 0, you'll get sine of x minus sine of x, which is 0, divided by delta x, which is also 0. 0 upon 0 is undefined. So keep moving. What should we do? Now, normally what we would have done at this stage is when we had radicals to deal with, we multiplied numerator and denominator by the conjugate. That might not work here. What we have to do in this case is to bring to bear our use of factor formulae. No, to catch y'all. You forget all your trigonometry, huh? Well, now it's coming back to bite you. My numerator looks like as if it's in the form sine p minus sine q. Let's remind ourselves what that looks like. Sine P minus sine Q is equal to, well, I gotta look it up myself, is equal to 2 cos of P plus Q over 2 times the sine of P minus Q over 2. There. Sine P minus sine Q, 2 cos P plus Q over 2, sine of P minus Q over 2. So, sine of x plus delta x minus sine x. Clearly your P is x plus delta x and your Q is just x. So that will be 2 cos P plus Q, x plus delta x plus x over 2 times the sine of P minus Q. P is x plus delta x minus Q, which is x, upon 2. That's part of the the 2 is part of the function of x, sine of that function. Okay, if we were to simplify, this becomes 2 cos of 2x plus delta x upon 2 times the sine of x minus x disappears, and I get delta x upon 2. Okay. So if I were to substitute back into f prime of x now, up there, because all I did with this piece of trigonometry here was to simplify my numerator. Took the difference between the two trig expressions, and I rewrote it as a product. So therefore, f prime of x is equal to the limit as delta x approaches 0 of, let me write my product, 2 times the cos of 2x plus delta x upon 2 times the sine of delta x upon 2 all upon delta x. Let's remind ourselves that we could if I divide numerator and denominator by a half, that would get rid of that 2. Yeah. What I'm going to do, I'm going to separate this into two different limits. Remember, limits distribute over multiplication. So in this case, I want to write this as follows. F prime of x is the limit as delta x approaches 0 of the cos of 2x plus delta x upon 2 times the limit as delta x approaches 0 of the 2. I'm bringing the 2 with the sine piece. 2 times the sine of delta x upon 2 upon delta x. Right? I split this into two parts. I split this into cos of 2x plus delta x upon 2. And then the second part is 2 sine of delta x upon 2 upon delta x. Now, see if I can do the magic here. That second limit, does it look familiar? Does it look as if it's in the form, or close enough to be in the form, was it sine theta upon theta? Except the limit as theta approaches 0. Except it's in the form sine theta upon 2 upon theta. So I kind of need a theta upon 2 to join that, don't I? So what I'm going to do, I'm going to divide both numerator and denominator by 2. Let's see if that makes sense. Let me get rid of all this. So f prime of x now looks like the limit as delta x approaches 0 of that first part, which is cos of 2x plus delta x all upon 2, times the limit as delta x approaches 0 of, if I divide the numerator by 2, this 2 will disappear. So it'll just become sine of delta x upon 2. And if I divide the denominator, which is delta x, by 2, I simply get delta x upon 2. So you like them apples again? Yeah, sure, apples we're dealing with here in this math. There. And everybody should know what this entire second limit is. We went through an entire video for that. The limit as delta x approaches 0 of sine delta x upon 2 divided by delta x upon 2. That limit is 1. That entire piece is 1. For the first portion, we're going to simply substitute the delta x equals 0 in there. So f prime of x becomes, I'll spell it out, cos of 2x plus 0 upon 2 times, and the second piece is just 1. 2x plus 0 is 2x. 2x upon 2 is x. Cos x times 1 is just cos x. F prime of x is cos x. I like this. So if we were to summarize, if f of x is sine x, then by first principles, f prime of x gives me cos x. Nice. Okay, I'm going to do one more problem. Some of them are lengthy, aren't they? I'm going to do the one with cos 2x. So I just did that one. Now f prime of x is cos 2x. Remember what you get when you differentiate cos 2x? Cos of f of x gives you minus f prime times sine of f of x. So that should be minus 2 sine 2x. Let's see if this gives it to us. Cos 2x. And this one here. Let's start again. We know that f of x is cos 2x. F of x plus delta x is cos of 2 into x plus delta x. There. F prime of x by definition is the limit as delta x approaches 0. You write this enough times, you remember it by heart. Of f of x plus delta x minus f of x all upon delta x. Okay. Which in this case would be the limit as delta x approaches 0 of f of x plus delta x is cos of 2 into x plus delta x minus cos of 2x, all divided by delta x. We're going to do something similar. We're going to massage my numerator, which is the difference of two cos expressions, and we're going to rewrite that as a product. Let's remind ourselves what cos p minus cos q looks like. Cos p minus cos q is equal to 2 times the sine. No, these things got minus in it. Yes, minus 2, man. Sum and then the difference. Hello. I know this thing. should know it. Yeah, is equal to minus 2 times the sine of p plus q over 2 times the sine of p minus q over 2. I'll double check. Y'all are supposed to be the experts now. So therefore, cos of 2 into x plus delta x minus cos of 2x is minus 2 times the sine. P plus q would be 2. I'm losing my... the p is 2 into x plus delta x plus q, which is just 2x, upon 2 times the sine again of p minus q, sine of 2 into x plus delta x minus 2x upon 2. There. Cos of 2 into x plus delta x minus cos of 2x now looks like minus 2 times the sine of 2 into x plus delta x plus 2x all upon 2. Should I simplify it? Yeah, maybe I should simplify it. Inside this bracket here, if I open the first bracket, that is 2x plus 2 delta x plus another 2x, which is 4x plus 2 delta x, which is 2. Yeah. Let me do a little side working. This is 2x plus 2 delta x plus 2x all upon 2, which is 4x plus 2 delta x upon 2, which is 2 into 2x plus delta x upon 2. These two cancel out, so you just get 2x plus delta x. Yeah. Yes, this is just 2x plus delta x if you were to simplify that. I could have even just factored out the 2 from the beginning. This is 2 into x plus delta x plus x upon 2. These two will go. X and x is 2x plus delta x, yeah. Algebra. All right, and the other one is, let me spell that one out too. If I factor out the 2 from there, I'll get x plus delta x minus x with a 2 on the outside over 2. These will cancel out. X minus x will cancel as well. I'll just get delta x times the sine of delta x. Well, what do you know? This one looks a lot simpler. Okay, and all I got to do now is to substitute that into my f prime of x expression, because this here simply represents my new numerator, this guy. So f prime of x, let me make a little space. Yes. There, f prime of x is equal to the limit as delta x approaches 0 of minus 2 times the sine of 2x plus delta x times sine of delta x, divide that by delta x. Again, I'm going to split this into 2 separate limits. I can leave the minus. In fact, I can pull the minus to clean out. You could always pull out a constant outside of a limit. F prime of x is equal to minus 2 times the limit as delta x approaches 0 of that first part, which will be sine of 2x plus delta x, and times the limit as delta x approaches 0. And the second part will be the sine of delta x upon delta x. Again, this portion right here, when I find the limit, that will be 1. Here, I'll simply substitute the delta x equals 0. So I'm actually going to find the limit now. F prime of x is equal to minus 2 times sine of 2x plus 0 times 1. F prime of x is equal to minus 2 sine 2x. Very consistent with our classical differentiation technique. Summary: if f of x is equal to cos of 2x, f prime of x is equal to minus 2 sine 2x, which we just proved from first principles. What? There. And I'm going to leave that one there. And call an end to this video. Now you have a worksheet this time. Haha. Let me modify these a little bit. I did cos 2x, but notice I gave you sine 2x there. I'll put a 5 in front of it. 5 constant times. Put up here a little bit more. 5 times. Anything else I want to change? No. No. Maybe. I'll put a 2x squared, 1 minus, there, 2x squared. I'll make it a 3. Make it different from the 2, there, 3. All right, this is your worksheet. For the last 2 videos, notice there are 2 videos on limits, differentiation from first principles. I thought it would only take 1. But apparently I had to split it in 2. Remember, my general goal is to not let any video go over 1 hour. So this probably took about 45 minutes. I'll see just now. All right, that's it for this video. As you can see, the next thing I'm coming up with is integration and applications. That stuff on first principles completely finishes for us. Differentiation. If anybody spots anything in the syllabus that I may have missed, I doubt it, but it's possible. Let me know. All right, that's it for this video, and the next one I'm coming up with, I'm doing them one after the other. This is Thursday morning, so by around midday, I'll be finished with all of the videos for my Pure Math Unit 1 class. All right, that's it. I'm out.